good. So then let's do the next step. So currently what we have done is only to actually turn the single parec file, which has all the data from one run, into a single Nifty file. And somewhat unfortunately, SPM still works on single volume files, so 3D files and not 4D files. So this is now a 4D file, meaning it has all of the volumes that we acquired during one run. I think it's like 440 or something in one file. So this is why this is fairly big. And the next thing that we have to do to make SPM happy about how to interact with these files is to split that up. And from now on it's always the same thing, so we can actually get rid of our import here so that we don't get this warning anymore, and also this. It's always the same thing essentially, so let's see how often we repeat it in this way, because at one point I might just copy and paste, but maybe not. So to split things up, there's also, of course, a batch utility, which I have to find here. Yeah, it's 4D to 3D conversion. So we have a 4D file, meaning that the temporal domain is also in the file. And now we want to split it into 3D, so many 3D files, because SPM wants us to, not because we really want to. But, so this is essentially how you click it, and then it will put that into either an output directory or the same directory, and we might as well keep it in this directory. That shouldn't hurt much. So what happens, maybe let's first save this as a script. 4D to 3D. Just that you know what's going on. So there's again the fever going up. I don't know. And this is actually what's happening. So this was our 4D file, which was quite large. And now this gets split, unfortunately, into 441 single files. And I should again disconnect so that we definitely have no sync here. And yeah, then the logic is always the same. You can write a script that is then, of course, nice for reproducibility using these things. Yeah, I will. And for the 3D file conversion, so maybe let's split this into data format or something, and 3D file conversion. And yeah, I mean, you don't have to call it job. I always call it job because it's shorter than MATLAB batch. What you cannot change are the fields of that structure, because these are the fields that SPM and SPM Jobman expect to have. I mean, they are also kind of meaningful, of course. So this means that you use the utility subpart of SPM, and then here we used import, and now we're using split. And the file that we want to convert is the output of the previous stuff. So No, that was in a different directory, so we have to again specify this path somewhat directly. So first let's initialize the job structure. So this now deletes the job structure that was here, so that there's no strange interactions between the different job structures. And then the volume that we want is, of course, now Rundia, yeah. So it's Rundia. It's now the run specific directory, which we created up here, and then the file has again already at this point one could use a filter. So later on we will not specify each, or will we? No, we will not specify each file name individually, but here we might as well still do it because we only have one file. So we can use again this trick here. That's this part. So cd underscore the run, and then see. So that's the file name, and then underscore .ne. That's now the Nifty file we want to split. It's actually a 4D Nifty file. Only 3D conversion. So again, we have to pass the file name in this cell array. And then when we decided that we didn't specify an output directory, this is then converted into this input argument of an empty string, and this means y 3D file output directory equals the 4D file directory. And then again it's always the same, then we run the job. Of course, what now happens when we run the whole thing is that first of all the directories are removed, then it's again doing our import, and then it's doing the 3D file conversion. So as these scripts get longer and longer, of course the steps that are before the current step that we're interested in, they also get carried out. At one point you might not want to have that, but I think so. Then you can comment out previous stuff. But I think in the interest of reproducibility, it's important that you know that your script runs from beginning to end and does the whole thing. Yeah, I don't see much of a point that you kind of start putting in options in terms of if I put a 3 in, only do this step and so on. So you can do that during debugging, but I wouldn't for the final script that you want to share with your paper. I wouldn't recommend to have these kind of options because that's not what you want anyway. Let's then maybe be done a little bit quicker by just, in this case, using the first run and see whether we get to where we want to get. Don't do anything. So you see that our other runs and the stuff that we have converted is gone now again. From like we need to get done with the project perspective, you have just deleted everything that you did previously. And you might not like that if you are in this mindset of we do one thing, then we have that, and then we do the next thing. But really what you want is, and what you also, so it doesn't work. Oh, that was something else. That was me. What you really want is not the stored data in terms of, okay, now we have the data stored as realigned or as this and this. You want, essentially, you don't want to store this kind of data anyway. You want to store the transformation that you apply to the data, which is your script, and the raw data. All these intermediate files that we create now, actually I also have a script for that I always adapt to delete them at one point. Yeah, so of course you don't want to delete them before you actually use them. Again, our thing is not working because something is misspecified. But there's something wrong. But you want to. Oh, where was I? The thing came. So. Yeah, you don't want to store the intermediate files. You want to have the raw data and the script, and the script is essentially holds all the information that is done as transformations to the raw data, and then you can delete all intermediate files at one point. At this point, maybe not. So here something is misspecified. I think it's run. What is the problem? No, that's there. _1. Up there, yeah. So the _1 is missing because I didn't think of it. So this is fairly typical. I think I deleted that, but we need it. So let's see whether we're happy now. Now it cannot be removed because I'm looking into it. So now, because it's always trying to remove things, if you are currently working in the directory, then it can remove it. So let's see what's happening now. Questions right now? Because we have to wait for SPM.
Why did you put an empty string inside the output directory?
Yeah, this is what so when we specified that in the batch editor, the only thing that we had to specify is which file we want to convert, and then we had the option to specify the output directory, but we didn't have to specify it. But what is the default then in this utility is that there's an empty string specified for the output directory if you don't specify the output directory. Because, so now it's running the 40 conversion. So the batch editor only asks you for things that are really, really necessary and uses some defaults. And when you see this then in the actually job structure, these defaults are also there, although you didn't specify them. Yeah. So now with the right file name, this looks better. Actually, we can also look here. And let's get that quicker. So we have now the first run only, and you see that we now have many Nifty files, and we have 441. This was our big original Nifty file, and this was now the splitted file, and each of them is a API volume, so you can actually look. Now the script is so great that it also removes, of course it's great, and SPM is already removed again. So let's add this to the path and have a look, because we will actually also write a script, or one can of course also write a script that makes pictures of the files automatically. So I'm actually not quite sure what it does when one tries to look at a 4D file. Let's see what it does, whether it complains. Maybe use display for this. So this is our 4D file. Let's see what it does when we try to look at it. I guess it shows the first one. Not quite sure what this should be. But now let's look at a single for file. So yeah, so all of these nifty files now are API volumes, as you can see. So ventricles in white, and as you also see, we only scanned visual cortex primarily because we're interested in visual responses, and cut off everything that is above this line. Good. So far so good, and I also recommend to look at these files during pre-processing, and then in the end also make a picture of all of the files over pre-processing. Let's now then do some realignment. And yeah, can get rid of that. So during realignment, what you would do if you use the batch editor is the following. So realignment meaning spatial realignment, meaning motion correction. There you always have these options: realign estimate, realign reslice, and realign estimate and reslice. So estimate means it just estimates the parameters that are used for this affine transformation between any two volumes with respect to with respect to the reference that you use. So estimate means parameter estimation only, and reslice means also to interpolate the volumes where they should be interpolated. So basically modifying the volumes in such a way that that the affine transformation is corrected for. So if you only want the parameters, which you sometimes want for using these parameters for something else, you might choose realign. If you don't have any parameters and you try to reslice, I don't know what's going to happen. But if you want to do realignment and have the realigned volumes, then you choose realign, estimate, and reslice. I'm almost like an SPM traits person. It's awesome. And then the question is, what to realign to? And this you can actually specify, and it has to do a little bit of how you do this. Let's have a look. Well, let's go. So session means run. We are still in the SPM world. And then we now want to realign all of these volumes, so we have to select them. Oh, we forgot one. Let's hope that this works. And here we could add another session if we wanted more session at this point, so more runs, but at this point we only want one because we actually only have data from one. So let's delete session 2. And then there are many, so you see that we can also run it now. There are many estimation options. And you can actually get some information about what these options do. It's like with everything in SPM, in the end, the definition of what's going on is actually in the code only, and you will not find a paper that describes all of these parameters nicely, and you can understand what they mean in computational terms. So yeah, so one could do what I'm doing currently in the summer term for the SPM p-values, also for the realignment, in the same kind of manner. For myself, I've decided realignment is great, but so pre-processing is great, but I focus my efforts on the statistical modeling because that's where the theory comes in. So I try to understand what most of these things do, and they are documented to some degree, but then in the end, who knows? So these are all the options, and if you yeah, maybe let's go over them. So separation, that's smaller sampling gives more accurate results. So this is how much, also let's start from the beginning. Estimation options, quality, selecting the number of voxels that are being used. So 0.9 seems to be the default. We go with the default. Separation is the sampling in the reference image. So the image where the parameters are estimated with respect to. That's specified here. Smoothing is not the smoothing that is done during GLM analysis. There is some smoothing also done here during realignment before the parameters are being estimated. Then register to first images in the series or mean. And somehow I'm under the impression that register to first is still what people usually do, so we actually deviate from the default here. This is the interpolation method for reslicing, which is a B-spline method. So splines is an interesting mathematical framework, so learn about splines in your own time. Direction in the one with the value should wrap around. Yeah, we are using no wraparound, which is good. We don't wait for some reasons. So these are all the estimations options. And the question is, sorry, this was the interpolation during for estimating the transformation. Now under reslice, we specify what we want to reslice, and in this case we want to reslice all of them and the mean image. We don't need to do that, but maybe let's select this one for the sake of it. Interpolation, how is the interpolation now for the real reslicing done? Again, B-spline techniques, no wrapping. We want to mask the thing. So there is an SPM mask which you can also find somehow, and this is being used. And then the question is how you want the files called, and this is with Realign. So you can modify all these options. In general, I think where one deviates from the SPM options is only in the register to the first image, and that's about it. So let's save this as a batch file. But the important thing is that, of course, all your choices are documented in your script. They also document it if you save this as a MATLAB batch file, but here everything is documented. And now the task is to actually turn this into script form. And I will not run the realignment now because we just take time and we focus on putting this into script form. So as I said previously, so the whole anatomical, so there's a whole research field that is called computational anatomy, and whatever we do in this realignment and anatomy, spatial pre-processing and so on, there's a lot of theory behind this. Yeah? So this is not trivial. I'm just not going and have not delved into the details of everything there because lifetime is limited. So, realignment, spatial realignment, also known as motion correction. So what we have here are all the file names. Of course, I mean, we could stick this into a script like this, but it's not very nice. So we will write something to select images in a second. What we definitely also use are all the options that we set. So these are our options. Can I call it job? And then the question is, what do these things do? Well, you have some information about this. This is the so you see the logic of this job structure. There are the estimation options. Oops, no. Estimation option quality. Estimation option separation. Estimation option smoothing. And this is maybe the most interesting, estimation option reference. So this is registered to mean, and this can be 0, and then it's registered to the first one, or 1, then it's registered to the mean. Here it makes sense to think a little bit about. So that you can write in your paper that these were registered to the first image and not to the mean image. Reference volume maybe. This is an estimation option, interpolation for estimation.
Why would you use another interpolation for the estimation than for the realignment?
Yeah, it somehow needs to define on where, from which points it wants to compute the transformation, and maybe it doesn't want to use your original coordinates where you acquired the data. But if you want to know the real detail, try to figure it out. I don't know. I mean, one would have to look into the code, how it's actually doing it. Related to some paper that was like written 10 years before it actually was implemented, like it's in there, and then somehow bring together what this is now doing. So this is again, so the whole computational anatomy would be like a full statistical methods course. So sorry. Yeah, it's actually annoying. So I think it's not good for the cognitive neuroscience field that it's like this, because these, like I said, I mean, this is what we're doing in the summer term in the p-value business. There is now software that is written, and there is a literature, and these two don't go hand in hand. And this is not good, because the main problem, so the main reason for that is that people are not interested in the literature that much, because this would be very mathematical, and then people don't want to do the math, but want to realign the data. So I want to realign the FMI data like myself, but I don't want to go into the math. So I use this software, and then nobody knows again what's going on. So ideally, in an ideal world, all the SPM functions, there would be a nice literature that explains what's going on. And in some degrees, we are trying to actually do that, but I always tell myself I don't want to do this anymore, because it's, why am I doing it? So, I mean, we have this paper from last year about the different forms of maximum likelihood estimation, which is basically doing this. We will have this new paper on the SPM p-values. But, yeah, just when you write, if you write some computational stuff, then write a nice paper that explains what's going on, so that these kind of things don't happen. Estimation parameter wrapping, whatever that means. Estimation parameter weighting. This is this realign, and so this is resampling. Resampling option. I think this means all, but not the mean image. Of course, that's what we selected. That's resampling. Fourth degree blind population, blind population. Exactly, that does. That's resampling using mask. So this mask is essentially, I guess, masking out subcortical structures. That's usually what this mask does, but one can look at the mask. Maybe we should do that. And that's the prefix. Output file prefix. So let's not at this point look at the mask, but first what we haven't specified so far at all the data. So we need to specify also all of those. But as I said, we don't want to put them in the script like this. But I will create a variable that is called fs in a second. previous stuff. And I will comment out parts here now, because I don't want to do the conversion each time now. For debugging the realignment. Once this is debugged, then of course you can put it in again. And finally, we need to specify the data, and for that, at one point, I wrote some code, and I'm adapting this. We don't have it here. But I guess I can copy it from here. So now we have to specify which data we actually want to realign. And as you saw that in the batch file, this is done doing, yes, manually done. So we have to find these files and specify the data in the form that SPM wants it. And for this, like I said, I wrote some code at one point, and I want to use this now. So this is what I'm now copying from the scripts that you also have as example scripts in the Smith directory from this other experiment. So I want to actually do the realignment overruns. So I'm using again a for loop overruns like here. Of course, I could also do it in this for loop, but as I said, we do it step by step. And for each run, we want to specify, this is why we need that here. We want to specify, which we could also have done in the batch editor, a run specific set of files. Then of course we need to, it's not good if we put this up here. And here we are doing it using the filter options by SPM. So SPM has a function that is called SPM select, which is the function that is called when you do this in the thing. And it has an option list, so it creates a list. And it needs to know from where to list. So it's something like, you know, the MATLAB dir function. So if you do this, you get a list of things, and SPM has something similar, which is called this SPM select with the option list. And but this you can filter, so you can specify what kind of things you want to have, and then it needs to be then it needs to be turned into the right format. How can we do that? Do we have anything? Because that's a fairly long expression, which is just annoying. Well, I can hopefully do it correctly. So we will first list the files that we are interested in, and then we have to convert it to a cell string. So this is ideally you would copy and paste this, and I would also copy and paste that from my old scripts. because this is just prone to go wrong. Oh, I really want to copy that. I don't do that now, that's too annoying. So the more important thing is that we specify the filter and the run directory. So we would just want to get the file names. This is all we're doing here, but I want to have the code. It's too annoying. I have to go away for a second. Oh, how do I do it? I can do it like that. Sorry. Because on this computer I don't have access to all my stuff, but in my Google Drive I have all of this stuff. So you saw that I'm interested in Viva. Because it was suggested. Wasn't as bad as I thought. So now I have the code that I wanted. So this one here. So this is how the data is specified. This, of course, we have to adapt for our current purposes. But then run dir is already clear, so we don't have to do that actually. We'll also have to put this here. And then there's this final step, which I just didn't want to do by manually. Where this list that we create is actually converted into the format that SPM wants, which is just annoying, but it has to be done. So let's first go up to here and see whether that works, because this is where the data is specified. And we have to give it, we have to of course tell it what to do. So we have to tell it to go into this directory. So this would be, what do we call that? Run dir. I think run dir might be the way to go, right? Patient, tree. And here. Oh, but there we have there we cycled overruns already, so we better make sure that we do that again. So run directory is this. And that should be all we actually need. So this is the filter, file selection filter, that we will pass to the SPM select function, which will then look up all the nifty files in this directory that are of this format. We have to then only make sure that we don't have this one file in there, which is the 4D file. So let's see what happens. Okay, not too bad. Run. Just have to. So there's this _1. So this is now, there's now _ too many. No. Okay, so I will, this is really nitty gritty stuff, so it's just specifying the list of files that then gets entered into the SPM job structure. I will, because I'm now getting hungry and concentration goes down, I will figure that out. It takes like 5 minutes over the week, and then you have it, but yeah, we will come back to that because we need it again and again, because you always need to select the files that you want to do the next step with. So now we are selecting the original files and we want to realign them, and then the next step we want to select the realigned files and normalize them and so on. So it's hierarchical, and this code that I have for that is actually doing that automatically, and it's really good, but I don't get it adapted right now because I'm hungry. Good, then let's stop here. You have what we've done, and I will just modify that so that it's actually also doing this, and then we can actually much easier copy it within the script from now on once it works for the first thing. Yeah, good. Then see you tomorrow.